Dimensioning multi-view sketches. Hello students. I'd like to take a few minutes to show you some of the techniques that you can use to dimension multi-view sketches and show as much of the size information as is needed to manufacture a part. So we're going to take a look at a couple of sketches that I've done and take a look at how dimensions are added to those. So this is the first sketch that I have produced. It is a basic L-shaped object like this. It has what I would call a tall tower section in the back and then a lower, more horizontal section here on the front. And you can tell a fair bit about it by rotating around. I have chosen to look at it from this direction to be my front view, which I've produced in the lower left corner. And then if we rotate that 90 degrees in this direction, we see the top view, which is located directly above the front view in a multi-view. And then if we go back to our front view and rotate in this direction, we can actually see the right side view, which is located directly out to the right of the front view. The purpose of dimensions in a multi-view sketch is to provide enough information so that a technician could actually manufacture and produce this part. So we want to give detailed information about the smaller parts of the object, and then we also want to provide overall dimensions of the width, the height, and the depth of the object. So that's what I've done at this point. So I want to walk through some of the particular dimensions that I've added so that you can see what's going on, and then give you some tips about some ways that you can make these workable here. Over here on this side of the object, you can see for that lower section I have included the height. That's going to be critical for a technician to know. So what we've done is started a little bit away from the corner of the front view. There is a little gap right here, and we have produced an extension line that comes out in this direction. This is extending away from the view. We have another one with a little gap right here from this top corner coming out this way. And then what we've done at this point is a little bit of dimensioning technique that we don't see all that often. But since that space in there is a little bit tight to put the number in, which is 3/4 in this case, what I did is actually come to the outside of the extension lines and added a dimension line with an arrowhead on it that points in toward the dimension. Usually these would be inside the extension lines pointing out. You'll see those in some other spots in this one. But for the sake of making it more readable, we let those point in. When you have tight dimensions, that's an okay technique to use. And then stepping out from that, we have the overall height of the object. All the way from the bottom, all the way to the top, an extension line going all the way back over to this point, a gap here. And you can see in this case, we've got our dimension line with the arrowheads pointing out, which is more typical. Right? So we've done that. Looking at width dimensions, we put the width of the tower section up here. Same technique with the dimension lines, arrowheads pointing in. And then coming off the top view up here, we put the overall width. Now we could have come off the front view right here, brought that up, and put that dimension kind of in the same place, but referencing it from the front view. I chose not to do that because I could get the same dimension and bring it away from the top view and have much shorter extension lines. That's one of the things that I always want to try to do, is keep these extension lines as short as possible. We've also come up in the top view and we've done this 3/4 dimension for the depth of the lower section, and then we have given an overall depth from front to back. Now you may notice in all these situations we actually have left a detail dimension out. Like here we did not give this dimension. if we give one detail dimension on this object and the overall dimension, the technician will be able to do a math problem and actually come up with what this one is supposed to be. That makes the dimensioning process quicker. That lets us get more done in a set period of time, and it also gives the technician a little bit of leeway in how he or she manufactures that part. So that's a technique that we use. The other thing I want you to notice is we have smaller dimensions located closer to the view. The very, very smallest dimensions will be closest to the view, and larger dimensions would be located farther away. So it's almost like they stair step out if you have several of those of varying sizes. In this particular case, we have placed all of the dimensions that we need to produce this part on the front and the top view. We did not have to put any on the right side view. We could have put height dimensions over here because they relate to that view as well, and we could also put depth dimensions across this direction on the right side view because they relate there as well. We just chose to put those over here, and this kind of congregates those in a smaller area. It makes it a little easier to find those dimensions. So basic techniques: keep the smaller dimensions closer to the object, larger dimensions farther away. Use extension lines. Leave a gap between the view and the extension line, and in tight places you can let the dimension lines point into the number. Right? So those are some basics that we want to look at. One of the other things we always want to try to do is we want to keep all of our dimensions between views. So you can see these two height dimensions are located between the front and the right side view. These two width dimensions are located between the front and the top view. And these depth dimensions on this end, I consider those between the top and the right side view, because they both relate to those. So that's an in-between area. I want to keep all these dimensions kind of in this area in which I am working. So let's take a look at another example. So in this case, we've done a multi-view sketch of another object. This one is shaped this way, and you can see it has some tall sections of varying heights. And when we rotate and look at the top, you can see it's just one thickness going back, and then if we go to the right side view, we can then see how that is formed there as well. So looking at this particular object, we've gone in, and similarly we have put a detail dimension down here, the height of that little low section, but in this case we chose to bring the overall height over to the right side view. In that case, we can keep the extension lines very short, where if we put that off the front view here at the top to bring one over, that would be a really long extension line. So it works a little better to put it over here. Up here we have several dimensions of width. So in this case, we have 3/4 for this first notch, which actually locates that corner where it would start. And then we have this top section, or tallest section, being 3/4 of an inch wide. So we've given those two dimensions, and then given the overall width coming off the top view. So smaller dimensions are closer to the object, bigger dimensions are located farther away. We have given overall thickness right here, and that's all we have to do with thickness. But in this case, we have what is considered a rule breaker. We've got a 3/4 dimension over here that shows the height of this notch, and we've given it over here. It really should be between the views if we follow all the dimensioning rules. But there's another something to consider. If I brought that dimension over here, my extension line would have to cross part of the object itself, and that's something that we never like to do. We want to try to get away from that at all costs. So while this dimension technically is breaking the rule of not being between the views, it works just fine over here and actually makes the drawing more readable, since we don't have to cross the view with an extension line. And we can tell exactly what the shape of the object is without causing any irregularities or making anything tough to see in that regard there. So sometimes you have to break a rule to make the drawing more readable. In this case, that's what's happening here. So once again, keep in mind, extension lines should always have a gap They should not touch the view. We should bring smaller dimensions out from the object first. Larger dimensions would be located farther out. Dimension lines are lines from the number that have an arrowhead on each end and show us from extension line to extension line where that dimension goes. The dimension line should always touch the extension line, as they do here, as they do here, as they do in all of these. So I hope this video helps you. Dimensioning can be a little tough, knowing exactly where to put them, and maybe this gives you a little better idea of where some of your dimensions need to be located and how you can include those on your multi-view sketches. Thanks for watching.